we're marking exercise 1, page 3. The homework sums we're busy with. Exponents. What rule has to be applied here? Where can I start? And remember your middle name is now? Alternative. Because there's always an alternate answer that you can go get. Who wants to give me the first step that you would like me to do? Yes, Daniel? Okay. You want to divide the numbers because you can simplify them first. What could you do? You could first put in the 2. If we first go and sort out the numbers, what are they going to become?
They're going to be 4 and 5.
4 over 5. Do you agree? What about the sign? Will stay a negative. Nothing happening there. The x and the y can do nothing because they are not the same basis. So they'll be left as the same as what they were. So when I go further with this one, now I'm going to have to, there's nothing else to do. I'm going to have to apply the exponent inside, which means it's first applicable to the negative, becoming a positive. If you want to put the positive there, feel free, you can. You don't have to. Then we're having 4 to the power 1 times 2 is 4 to the 2. But we like to write 16. At some stage you're going to write 4 to the 2 as 16. If there were more powers there that you could simplify, you would do that first. But this one you can just simplify that way. And the same with the 5, it's going to become 25. Can I jump around like that? As long as you've got a method. So we've got 1 times 2 is 2, so 4 to the 2, you can still write 4 to the 2. And then x to the power of 6. Excellent. You don't add those exponents. When do you add exponents? When you are timing powers, you keep the base and you are adding the exponents. So we've got exponents multiplied in. So we've got y to the power of 4. Will we leave it that way? Yes. No, we're going to take that y to the power of 4 to the top. And it's going to become y to the 4 over 25. Are you with me?
Yes, ma'am.
So I've got negative to a power 2. I'm making a video, man. So it's negative to a power 2, that's a positive. And I've got 3 to the power 2, that's a 9. So we've got a to the power 4, b to the 8. We've got
27.
3.
Oh no, yes, ma'am.
Yes. A to the 6. You saw your mistake, and b to the power 3. Just make sure that you're doing the right stuff to the right stuff. So that was the application of the exponent law that says whatever's outside that bracket is multiplied with every exponent on the inside. Remember that the 3 has a 1 there as well. First, the negative became a plus. Then that 1 to the power of 2. 3 to the power of 2, it's fine if you want to write 3 to the power of 2. At some stage, you're going to sort out the numbers. Maybe by first saying 3 to the 2, 3 to the 1 is 3. Or like we've done now, 9 over 3 is still going to become 3. But we've got to simplify. Simplification of base is the same, so I subtract the exponents. Yes. The numbers are normal numbers, they're just going to become 3 at the top, right? Yes. The A, the biggest one is at the bottom, so it's going to become a to the power 2 at the bottom. And b to the power 5 at the top. Anything else you want to do? No, that's the answer. Right? Then I gave you number 2A because it's such a silly question. But silly questions also get answered wrong. What do you have to do with this one? You're going to take this to the top, but that?
Anything to the 1 to the power of anything is 1.
Excellent. That's all that they wanted. To the power of, I don't know how much, is 1. 1 to the power of a quarter?
Right.
Anything. 1 to the power is 1. Right? Except for 1 to the power 0.
Yeah.
But it's still 1. Okay? And then we've got 2 to the power, 2 to the power of 1 to the power of 1. I'm finished. Silly question. You just have to take that to the top and realize that that was 1. So I don't think this would have been worth more than just 1 more. And does that 1 have to be there? Maybe just for my explanation purposes it was maybe a good thing, but it's it's just 2011. Silly questions can also be asked for an extra 1 mark. Okay, what did I tell you about decimals?
You have to make it a fraction.
And the fraction is?
1/8.
How did you get that right?
Calculator.
We don't know.
Or old school. You remember old school?
No.
Decimals. 125, that's great. 5, 6. 125 over 1, 2, 3 zeros, 1,000. And if you simplify and see how many times what goes into what, it's 1/8. Now to finish up here, what do? You can switch it, and then the 8 also, you can go to prime numbers. But you don't have to in this sum because it's not that difficult. If you switch it around, it's going to be 8 to the power of 3. So do I need to go to prime numbers? If you can just work out what is 8 times 8 times 8, that's fine. Answer?
512.
But if you did want to go and say 1 to the power of 2/3, because alternative is your middle name, and keep that minus there. 1 to any exponent is still 1, even if it's minus. And then this would be 2 to the power of -9. Bring it to the top. And the answer eventually with a longer suffering is still there. So they look completely different, don't they?
Yes.
And I can guarantee you, if you think hard and long enough, you'll get something else that also works. All right, let's have a look at number 2E. Now, you have to go to prime numbers for the bases. 8. All right, now always in grade 8, I teach the kids, please know your powers of 2 and your powers of 3. Because that is asked so much. Like knowing that 8 is 2 to the 3. If you know that 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3, 2 to the 4, 2 to the 5,
32.
32, 2 to the 6,
64.
64, 128.
256.
Okay, I think we've done enough, but are you getting my drift? Then immediately when I give you sums like this, you're going to give it to me like that. But your calculator, you put 8, equal and shift that. And it gives you the answer. Alright, and 9, hopefully you know that that is 3 squared. Has to be times still with the 3. Now guys, if in that sum, you could immediately say 3 to the 6, I'm happy with that. But you might have gotten confused why. Because you have to first say 9 is 3 squared. Then you're going to have 2 times with 3, not added, times. Same as with 32. We just said that 32 is 2 to the 5. And 27 is 3 to the 3. If you know the stuff, it goes so much quicker. 3 to the 1 is 3, 3 to the 2 is 9, 3 to the 3 is 27, 3 to the 4 is 81. Are you with me? The quicker you know them, the quicker these sums are. And you'll want to save every few seconds here and there. Because math always takes the time challenge. Now, I'm not quite finished and happy to go on with the sum simplification. I'm first going to write 3 to the 6 and 2 to the 10. Then we're on the law that says if the bases are the same, we keep the base and subtract the exponents and keep the one at the larger place. Where is that going to be? 2 to the 7 at the bottom. And 3 to the
3 on top.
3 on top. Now, do we leave it that way? No. I want to know that that is 27. And if you're really cool, you know that 2 to the 7 is?
128.
But you have a calculator. That's not what these laws are about, knowing that. Are you with me, everybody? Alright, the last 2 homework sums. What is there to do? Can you keep the base and do something to the exponents?
No.
Why not? Big fat plus saying, whoa, there's no exponent law for plus. So what is there to do?
Two underneath.
Put the 2 underneath, which makes that 1 over 16. Can I not immediately write 16 because I know my powers of 2? Yes, ma'am. 100% to say that that is 1 over 16. And this? 16. And the answer I'm happy. Most of your calculators will go with that and say 16 times 16 plus 1 and make it an improper fraction. That's what you've done. You've added a 16, with 16 and you get 16 and a 16. And remember, if you crunch your calculator and it puts it in that other form, please tell me what is 16 times 16 plus 1?
272. 272 over 16.
Whether you write it this way or that way doesn't matter, but can you take your calculator from improper fraction to normal fraction, please? Okay, can we check that?
It's 256.
256.
Yes, 257.
256. Plus 1.
Right? Okay, for this one, what am I going to do? Guys, you take this third at the bottom and quarter at the bottom. You cannot take them to the top. What stops you?
The plus.
That plus. So you have to do a little bit of exponent law here, a little bit of exponent law there, and that's it. But do we leave it this way? Why not?
It's by simplifying.
Three things on top of each other, never. How do I get three things on top of each other as two things on top of each other? You divide by a fraction and you make it multiplication by the reciprocal. Right. But to get the reciprocal of this, I'm first going to make this one fraction. That's the whole method. Whether it's normal numbers or A's and B's and all sorts of variables, it doesn't matter, the same thing. You must make it one fraction by getting the LCD. But getting the LCD of 3 and 4 gives me 12. And at the bottom, and I don't have, sorry, I'll have to keep on this one. I would have liked to have the color. 12, so at the bottom I've timed with 4. So time the top with 4 and you get 4. At the bottom you've timed with 3. At the top you time with 3 and you get 3. So that this is 1 over 7 over 12. And then how do I get it to be proper? You time with 12 over 7. And that answer would just be 12 over 7. You can first say 1 times 12 over 7 or just 12 over 7. Which is acceptable. Never three things on top of each other. But where's the exponent laws? Little one, and the rest was not exponents. So we don't just have to have exponents in a sum. Little bit of revision in today's lesson. If we multiply powers, there are rules. So in these rules, you were taught grade 10 to do what? If it's all multiplication, I didn't even put a dot there. Is that okay? It's okay. If there's a dot, or you can put the multiplication, just be careful for x's. So if there's lots of x's and multiplication, sometimes the x's become multiplying the other way around. Just be careful. So if all of these are powers, and they are being multiplied, what is the golden rule that we've just had in a previous sum? All of these, 8 and 6 and 9 and 16, you have to go to prime numbers. So that'll be 8 is 2 to the 3. But now, actually, I want to be a little bit lazy and say, let me make the 8 there already a 2 to the power 3. Then this will be 2 to the 3 n because I'm multiplying it. Because you can leave out that step if you're careful. The 6, let me make it a 2 times 3 so that I can skip that step and say immediately it's 2 to the timing in the exponent. N minus 3 because it's multiplied by 1. And again, n minus 3 multiplied by 1 is n minus 3. The 9 is 3 squared. And 2 times gives me 2 minus 2n. Both of them are timed with 2. 2 minus 2n. At the bottom, the 16 is 2 to the power of 4, making that exponent 2 to the 4n minus 4. And luckily for me, I had to do nothing with 3. It's just standing there looking pretty. Now I can see that there are bases the same, but they're not all the same. The bases that there are is 2 and 3. So you were taught in grade 10, you make one big fake 2 and then you add the exponents at the top and then subtract the ones at the bottom, because that's what you do when you divide, you subtract. Making it a nice rule to say all of those are just added, so it's going to be 3n plus n minus 3, right? And then this one will become minus 4n. Ah, excellent, plus 4. Because that is just added, but this is subtracted, so it becomes a minus, and then minus of a minus is a plus. Then we've got big fat 2 done. Here comes big fat 3. And we've got n minus what 3 plus 2 minus 2n, but plus n. So, this is a lot of work, but I won't give you 10 marks for this sum. It's 1 mark for all the prime numbers. 1 mark for all the timing out. Maybe 2 marks for each of them that you've added and subtracted the exponents, and 1 for the n. So it's about 5 marks for the sum. But it's a lot of adding and whatever. So now to simplify, this will be 2 to the power of. What do we add? Like terms by adding their coefficients. 3 plus 1 is 4n. Minus 4n is 0n, it's gone. Then we got minus 3 and plus 4 is 1. But the answer is just 2, yes? And then times with 3 to the power of n minus 2n is minus 1n, plus another 1n, 0. And then 3 to the power of negative 1 for negative 3 and plus 2. Is that fine? No, we don't leave it that way. We're going to say that this is 2 times 1 over 3, a third. Knowing that 3 to the minus 1 is a third, 3 to the minus 2 is a ninth, is something that you must get yourself used to.